Hello everybody, I'd like to show you some Python code that we've been writing to model supply chains in the OpenNo framework. I don't expect this to really make sense because it's going to be a very brief introduction. Here we have some basic Python code which allows us to define a supply base or supply network of things necessary to make a chair. And in our model, a chair consists of legs, a seat, and a back. A seat can consist of either fabric and a plane or fabric, stuffing, and upholstery, for example. So there are various ways these things can be put together, and we have what we call the characteristic equation, which says how many of each component is needed to make the item in question. From there, the fundamental question we want to ask is that of a supply problem. A supply problem is the problem of finding a particular item, like a chair, given a supply network which has been created in this way. So this is code which runs in Python. So having defined these various features, this little loop will loop over all of the possible ways of producing a chair and give us the prices for them in all the complete supply trees of this supply network. So here we have three different ways, maybe four different ways of making a chair which has a particular price. This one is based on chair design 1 and it has a price of 13. Slightly different way of making a chair is to use chair number 2, which in the best price has a price of 12. And there are more expensive ways in the same network of making those. We can use this system to easily compute an optimal plan because we know what all the prices of things are. It's also the case that we can build other supply networks, and in particular we can model the concept of a stage graph. So I can create a stage graph for finding a chair, and then I can ask questions of it. I can ask, for example, is it complete? That is, have we completed it? Does it need repair? And the answer right now is no. But then I can artificially assert that one of the things needed in the stage graph has failed, and then we can ask the question, does it now need repair? And the answer is yes, it does. And we can ask the name of the supplies that need repairs, and as you can see, that is seat 1. Then if we choose to repair seat 1 by replacing it with seat 2, we can then ask once again, does this stage graph now need repair? And the answer is false. It's a complete stage graph. We have a number of unit tests that we can execute against these various supply chains. And this is really the beginning of our computational modeling of the OpenNo framework.